rationalizing fractions. So the first thing we have to look at here is what it means to have an irrational denominator. So an irrational denominator is when you have an irrational number, so a radical that does not simplify, as the denominator of your fraction. So if I have the fraction 1 over the square root of 2, my 1 is obviously just my numerator, and my square root of 2 is my denominator. Okay? Obviously, you can tell that this denominator is irrational. Okay? So, in order for a fraction to actually be at its simplest form, the denominator should not be irrational. So, we cannot have any irrational denominators within our fractions, and the saying that goes along with this is no tenths in the basement. So, let's go over just a couple of examples and we'll save the rest for class. So, this will be a short video. So, whenever you're working with irrationals in your denominator, we have to do a process called rationalizing. So rationalizing pretty much means that you're going to multiply your fraction, both numerator and denominator, by a specific number so that you can simplify your denominator to no longer be irrational. So right now I have 1 over the square root of 2. So I need to think about my perfect squares because that's the only way to fully simplify a radical. So my perfect squares are 1, 4, 9, 16, so on and so forth. So looking at 1 over square root of 2, which of these could you multiply, or which of these could be a multiple of 2? Well, immediately 4 stands out to me because I could multiply 2 times 2 to get to 4. So I'm going to multiply this fraction by the square root of 2 over the square root of 2, which ultimately would just equal 1, so it's not changing my fraction at all. Okay? The key detail to remember here is when you're rationalizing square roots, you can just multiply the number by itself. Okay? So multiplying this, when multiplying fractions, you multiply straight across. So I've got 1 times the square root of 2, which is just the square root of 2, over the square root of 2 times the square root of 2, which gives me the square root of 4. Okay? I'm going to simplify my radicals. Obviously, I can't do anything to simplify the square root of 2, so we're going to just leave it. And the square root of 4 would just give me 2. So my simplest form for the fraction 1 over the square root of 2 is actually just the square root of 2 over 2. Okay? Let's repeat the process with our second example here. So once again, I have the square root of 2 in my denominator. So in order to rationalize it, I'm going to multiply this by the square root of 2 over the square root of 2. Okay? By doing that once again, I'm going to have the square root of 4 in my denominator. But this time, in my numerator, remember, when you're multiplying radicals, you're only going to multiply your radicands, so the value underneath your radical, and their coefficient. So in this case, my 7 stays the same, and I'm just going to take 10 times 2, which gives me the square root of 20. Okay, now I'm going to go ahead and simplify. So the square root of 4 just equals 2. And on top, I'll just have 7 square roots of 20. And that actually cannot simplify. Well, it can simplify. So let's actually do that. My bad. Spoke too soon. So at this point, let's simplify the square root of 20. I'm not sure if we would have covered this at this point, so just hang with me if this is something new for you. So once again, looking at my perfect squares, I'm going to simplify 20 by factoring it as a perfect square. So a perfect square that is a factor of 20 would be 4. So now I'm going to take 7 times 4 times, so 4 times what gives me 20? Should be thinking 5 over 2. And now I'm going to take the square root of 4, since it's a perfect square, and I'm just going to leave my 5. So the square root of 4 gives me 2, so I'm going to have 7 times 2, and I'm just going to leave the square root of 5 over 2. 7 times 2 gives me 14, so I've got 14 times the square root of 5 over 2. And then actually, this allows us to simplify our fraction. Just divide your coefficients. Divide your constants. So 14 divided by 2 gives me 7. So ultimately, this equals 7 square roots of 5. Okay? So right here, this step is the main goal of today's lesson. Everything that followed the simplification process, yes, we're going to work on it eventually, but it is not the main focus of this lesson in particular. All right, so hopefully this gave you guys just a little look into how to rationalize irrational fractions, or fractions with an irrational denominator. Please come to class with any questions you have. We'll make sure to go over plenty of examples of these. All right, thanks for watching.